Okay, this is chapter 8, number 50. It says you are at the controls of a particle accelerator sending a beam of 1.5 times 10 to the 7th meters per second protons, mass m, at a gas target of an unknown element. Your detector tells you that some protons bounce straight back after a collision with one of the nuclei of the unknown element. All such protons rebound with a speed of 1.2 times 10 to the 7th meters per second. Assume that the initial speed of the target nucleus is negligible and the collision is elastic. A. Find the mass of one nucleus of the unknown element. Express your answer in terms of the proton mass m. And B. What is the speed of the unknown nucleus immediately after a collision? So first, we're going to start out with the conservation of momentum. So we have m1u1 plus m2u2 equals m1v1 my u's and my v's kind of look the same. But we'll start with this equation. We have a lot of the information for this. So for m1, we just have m1, and then our initial velocity is the 1.5 times 10 to the 7th. And then the initial velocity for the second term is 0, so the whole term just goes to 0. And then we'll have m1. Sorry about that, there was a pop-up. Anyway, then we have our m1 again times the negative 1.2 times 10 to the 7th. And the problem, it gave us just 1.2 because this velocity was measured going one way, and that's measured going the other way. It's negative. And we can finish that off with plus m2v2. Now, this is the equation that we're going to need to solve part B, but we're going to set it aside for a minute. And for part A, we can use the equation initial velocity 1 minus u2 equals v1 minus v2. Yeah. And we have most of the values for that. So we can solve for our velocity that we need still. So again, we can plug in our values. 1.5 times 10 to the 7th. The initial velocity for mass 2 is 0, so 0 minus 0 equals our v1, which is the negative 1.2, minus v2, and that's what we want to solve for is v2. So when we solve for v2, it comes out to be 0.30 times 10 to the 7th. Subtract that from that and flip the signs, and you get your 0.30 times 10 to the 7th for v2. So that's the answer to A, but now we need to plug that back into this equation up here for B. So we'll have two variables, m1 and m2. The question wants the value of one of the masses in terms of the other. So we're going to do m2 in terms of m1. So we'll remove v2 and replace it with 0.30 and to the 7th. All right. Now we can move M1 over to have, well, I'll just work it out. So it's M1 and then divide by and then that comes out to a nicer number of just point, oh, that's 0.3. So it comes out to be 9. And 2.7 divided by 0.3 is 9 M1. So M2 is 9 M1. And that's all for Chapter 8, Question 50.